By the way, the image is taken from pixels and I gave the credit yesterday in my video itself. Just making it out here, you know. Okay, so this is not optimized image, it's just an image within src alt complete width, complete height, complete quality, and then I will simply build it. Cool. Yeah, fair enough. It built. Now let's start it. Go back, restart it. Now it is coming. See, it is a very big image. Now if I go and inspect, go to this lighthouse, uh, and simply analyze it for this mobile performance. Okay, it is doing what it has to do. This is related to something called performance optimization. It is one of the things that I am working right now in my company, and basically what I am working right now. Let's just put it that way. It's kind of like it's not, I won't say it's a good experience, but it's a very great learning experience because it's a lot of trial and error. Even though you know what has to be done, sometimes it just does not work for no reason. And there's a lot of reason. By the way, I know the reason, but it has nothing to do with the technology itself. Sometimes it's just the physics comes in because your laptop or your so-called desktop is able to produce something around 60 watt per hour or something, that much of a power, and in terms of like heat dissipation, whereas that much amount of power can burn your hand if your mobile device starts dissipating heat at that rate. And in electronics terms, power equals some like heat. You can just imagine it like so. And yeah, your battery is also not good in mobile, so basically you are pretty much destroyed by your mobile device's performance is not equivalent to whatever performance it shows here, right? It will be much worse. And the reason being that it is limited by the battery, it is limited by the processor, it is limited by the network speed, which is not equivalent to whatever the throttling you do here. But still it gives you some sort of like estimation key how like what is the trend, and I'll just show you what I mean by that. Anyways, as you can see, this is the score, this is the problem LCP, and everything else is fine. So in order to improve this all we have to do is fix this LCP, and this is the image. Well, it says the above the fold image that I lazily loaded rendered later in the page cycle. What it says is that this image by default is not being fetched as a priority to be high. So if I go to the network tab and if I click on this image, you will see if I click here, somewhere here there is a thing called priority. It has to be here. By the way, the content type, as you can see, is already WebP, even though the image, if you see here, is JPEG. So the Sharp is converting the thing completely fine. But, but, what I want is this. Where is something called priority? If I'm correct, it is here only. Or maybe I'm wrong, but it comes somewhere. Yeah, AVIF is greater than WebP. That's true, but I have just let the Next.js decide what to serve at this point. AVIF, by the way, is a latest format in even better and latest than WebP. So yeah, if the browser supports it, it can be supplied directly to that. But I think Next.js is deciding that it has to be WebP. One thing that you can do is that in this Next.js configuration file, this is something that was present even in the previous architecture itself. You can pass certain things like images, and then you can pass the domain. If you are using some sort of like a CDN, then you can pass a domain. You can pass a loader as well, like what loader do you want, and then you can also pass the format, and there you can define image slash avif comma image slash webp. And if you define it in that order, what the Next.js will try to do is it will try to convert it first into this avif if the browser supports it. If it does not, it will go to the webp, and if that also doesn't happen, then it will go to whatever the format you have given by default. But most likely all the modern browsers will support at least webp. Okay, that's a safe thing. So if I go to this performance insight now, see, there are three modes. Let's start with this. And here's what I wanted to show you guys. Like, this is something that you should be doing every time you are building a front end. Otherwise, you can actually go in a very bad direction in terms of performance. Start with this option called slow 3G, and then 6x slowdown of the CPU, and then also disable the cache. Okay, slow 3G, 6x slowdown, and disable the cache. Now measure the performance load. I cannot speak certain words at night for some reason. But anyways, you can see what is happening. The speed is slow 3G while measuring the performance, and the CPU is also throttled by approximately 6x. 6 times is slower than whatever the CPU is. So it's trying to replicate certain scenario what could happen in your mobile. And then also assume that your mobile will be like a little bit worse than that. Okay, but most likely you can't do much, except what you can do is apart from all of this techniques, the best way is to connect this real physical device. Buy any physical device or ask your company to provide you any physical device which is the bare budget phone, right? Because that's the phone that will be used by the majority of your populace, right? So if you are in India, like I am, what you want to do is get any phone, maybe 2 years old phone, which is less than 10,000 rupees, right? And then try to test it on whatever you are doing, test on that. You can see that that will be the real world performance for most part of your customers, unless you have a customer base which is tech savvy and rich enough to afford everything new. Then yeah, but even then you will not be getting the mobile I mean laptop performance anyways. So this is necessary. Cool. See, this is the LCP, 42 seconds, 42, yeah, 43 seconds around. Okay, and if you see the network tab, there's also a problem. See this image, this is the image which is, should I make it big? Yeah, this is fine. So see, this is the HTML, right? So first the HTML is loading. As soon as the HTML completely loads, then the CSS is loading, then the JS is loading. Okay, Next.js, and then RJS, whatever the RJS is. And once this is also loaded, right, then the image is being loaded. This is the image, green. Okay, and then the favicon is being loaded and the rest of JS. So this is how it is. Thing is, the LCP is done and dusted once the entire image is loaded. And this whole thing, and the reason why it is doing is because largest contentful paint is actually basically decided on if in your viewport, technically speaking, if you have a large image like we had right now, the LCP will be once that entire viewport is loaded, whatever the largest contentful paint is in that thing, in our case it's an image, once that is loaded, it will take that time. So in our scenario, the LCP is very bad. If we are on slow 3G, 6x slowdown. Now look what will happen if I just move this like fast 3G and do the performance testing again. It is right now 43 seconds approximately. And second thing that you had to note is that the HTML is loading first, then the CSS and JS, and then the HTML, then the image is loading. So it's not, so there's not like the image is being loaded lazily. Okay, that's what it means. Let's let it complete. And today I'll just be doing this performance thing, just showcasing it, and then we'll be like going off. It's too late at a night. Just wanted to come back because I forgot to do this yesterday, because I did not had the Google Chrome installed. Okay, fair enough. And now first thing that you have to see is Mhm. Okay, so this is what you have to see first. The HTML is again loading, then the CSS and whatever the JS is being loaded, and it is kind of like a waterfall model. And then here the image starts. This light screen or light green, or as you can see even here, the light green is basically the server response time or whatever, and then this is the rendering time of this page. So I mean, you got the information, but the browser is rendering. Okay, the same is true for here as well. Mm. Mm. Okay, the same is true here as well. So you got the information, and now from here to here the browser is rendering. Now the LCP at this point is somewhere around 1200 milliseconds. Yeah, here as you can see the priority is also low. Okay, it is not coming from cache and it is not coming from the service worker either. So caching is one of the techniques that you can actually do, but we have disabled the caching, so that's why it is not happening. Otherwise it will be picked up from the cache. And priority is low, which will solve this waterfall model for this image. So the moment we set the priority as high, what it tells the browser is that this particular image now, this particular image, you fetch it as you make the fetch priority property of this particular image to be like high. So you can look at from this perspective. There's a image fetch priority. Okay, here you will find HTML element. It says this is experimental technology, blah blah blah. You can go and search this browser compatibility, and come on, see, the only thing it is that it shows ki Firefox is not supporting it, right? Firefox for Android is not supporting and Safari is not supporting, but I think the latest one kind of like started supporting it. um, but this is exactly what we are trying to do, fetch property. It is experimental, but most likely Firefox will be supporting it. Let's see. Firefox fetch priority. This is also here, web dev. No thanks. Yeah, Firefox is not supported. Safari is in preview mode. Right. Okay. So in our case, Firefox is not being supported, but they are, I think they are building some sort of things. But Anyways, the you can do it in Next.js, and the Next.js will take care of it somehow. For the Chrome, it will, I think, default to the real way, and in Firefox, maybe it will do it, maybe it will not do it. I am not sure. So yeah, but if you look at this point, this is around 12 seconds. Okay, so from 42 seconds of LCP, we are back to around 12 seconds, or maybe, right, yeah, around 12 seconds, 12.27 seconds. And inside you will have DLs. Let's see, where is the LCP? I think it stopped talking about the LCP altogether. Yeah, it is not looking into the LCP. Don't know why. But LCP will be around 12 seconds now rather than 42 seconds, because this is the else largest contentful paint object. So it finished here, so it will be somewhere around here. Now what I'll do is I will slow down, like speed up the CPU again and measure the load one more time. Right, we are now in the like fast 3G, but and also a little bit faster CPU. And mind you, there is no optimization of the image till this point. Image is still the unoptimized image that we are serving, and whatever the optimization is happening is because of the inbuilt Next.js thing using the sharp tool. Okay, now you will see the LCP is now showing as 34.27 seconds, somewhere around here. And I think this is like, should be right here now. Why it is happening here? There's nothing here in the first place. I don't think this is, what is this? The image just completed here itself. Image completes here at best here. So let's assume it to be like 12.24 seconds, because there's nothing that is happening here in the first place. The main thread is blocked. What is this then? Navigation event, DSL, DCL, DOM content loaded. Okay, DOM content is being loaded, so I understand. Even though the image is like done here, the DOM content is still being loaded. Okay, but the image itself being loaded is like now 20 seconds or something less, but the DOM content is being loaded still. And there's some sort of like a task that is going on. And if I do it like a no throttling in terms of CPU, measure it again, let's see what happens now. Okay, so this is the problematic part, but the image loading is now again like somewhere around the same. If I just remove this no throttling part, everything is like no throttle. Why is this happening? This is new. Like, what DOM content is being loaded? If I just measure the page load again, everything is like fast now. When everything becomes fast, as you can see, the LCP also reduces from 32 seconds or something directly to 13 seconds. But this is still not optimized in a way that it can be done. And if I just make it like so, this is where the image is coming now. And here the main thread is being run. This is like what? Where everything starts. This is the run task. Then certain things are happening here. Finally, the favicon. But there is something called somewhere around here. Things are stopping. Okay. Now, if I just close this around 13 seconds or something. Now, what we'll do is first we'll add the priority, then we will add whatever the exact image size that we need in terms of width and height. We will let the quality be as it is. We don't care about that. Basically, in by default it's 75, but you can have it like set to 100 if you want a crisp image. Then we will build the entire thing once more. We can go back here while this builds up. Okay, it built, and we can just reload the page by starting the thing first. Then simply reload the page, inspect it again, go to our performance insights. Again, I will say no throttle, or I can do, let's go with the no throttle first. Here we will find that when nothing is being throttled at all, everything is like a full speed, we will see that DOM content loaded also happened within 0.1 second, and image and everything became like green. But more importantly, you have to look something like this. The waterfall model is what's more important. So right here in this network tab, you see that this is where the HTML is loaded, but then the task in the main thread starts running as well. This is where the image, I mean the CSS is coming up. Also, this is exactly where the image is now being fetched, rather than the before the JS is being fetched, because this is now as a priority, it is being fetched in parallel to CSS. Now, we just told the browser to fetch it as a priority element in our DOM, and then the browser will decide when to fetch it. You cannot manage it like to fetch it with this itself, like I mean with this itself, or with something here or something here. Like this is something that the browser will do. But as you can see, this is where the LCP ends. This might be our the main thread, after which everything becomes like interactable. So LCP ends right here. Okay, and DOM content loaded is also something that completes right here. But if I just reduce this network speed to slow 3G, I won't be reducing anything regarding the CPU. Simply measure it again, right? That part of this parallel loading, whenever the browser decides, will not change. What will change is that the render portion of that entire LCP. So LCP is divided into 4 segments: TTFB, time to first byte, which is a server driven scenario. So as a front end developer, you cannot do anything except maybe serve the pages, which is the static pages from the CDN itself. Then you have load time. Then you have there's a load delay, and then you have the render delay or render time or something. Render time is basically when once all your information after the first 3 steps is with your browser, but still it takes some time to render the entire thing. Okay, why this, like, I need the LCP? There was no LCP shown. Show me the LCP now. Also, just the network speed being slow, you can see that this entire thing was quite bad. So LCP became 14 seconds, right? On the slow 3G. Most likely your so-called person or so-called user will be sitting not on just slow 3G, but also on 6x throttle of the CPU in their mobile. Then you measure it again and you'll find something the real performance most likely. The only silver lining is that you can hope, for most part, your users have better mobiles, and the median, and when I say the median, I mean the 75 percentile of the uh, user base is at the green LCP range rather than whatever is the range that is being shown right here, the 14%, right? See, 14 seconds, it's a very bad thing. The reason why it's bad thing is because most users do not wait for more than 3 seconds, and that means 53% or something users leave after 3 seconds, and your highest level of, like, your page is still being loaded till 14 seconds. Okay, but what will happen if I just do it like a fast 3G? Assume that your users are on some better plane or better, or your user demographics is somewhat better, right? And even then, so they have like better network speed, at least 5G, 4G, whatever. Even though as the user base increases, these network speed keeps on decreasing, which is bad. But that's how it is. It's not like these speed go up. They're basically in a very simple manner. This is how the uh, mobile network speed behaves, to be quite honest. So you can think of this as like a y-axis, and this is like a x-axis. This x-axis will be your like time, and this y-axis can be your users. Okay, now in the beginning, something like, okay, so as the time increases, I mean, this can be speed. Now this is basically users and this is speed, right? And you can say in the beginning, when the users are like less, say any new network spectrum is released, say 5G, when the users are less, right, it will be very good speed. But as the user base increases, it starts decreasing, right? And somewhere it attains somewhat like a median scenario as the user base increases with time. And you can save users with time. Okay, speed, mobile internet. And this is true for any, like any country. It does not matter which country you belong to. That's why people who are in India, you guys can actually relate to that. it is just based on experience, to be honest. And that is to say, when the Geo released itself, in the beginning it was very great, like very great, to be honest, like huge speed, speed to be right, speeds were given. But as the user base expanded, the speed got divided, and speed decreased and became even slower, or sometimes somewhere around mid of 3G. The same happened with will happen with 5G eventually, as the user base increases. Okay, right now it's very good, but eventually it will decrease. Cool. And this is the like mobile network. Thing is, still with the fast 3G and 6x slowdown, you will find that at least your large LCP is 3.95 seconds. It should be some like, if you, I'm not talking about the like, don't look at the absolute number, you should be looking at the trend from 13 to 3. So it's that trend that we are talking about. Key, yes, with the increase in network speed, at least your LCP will decrease. And if you have like better CPU as well, and then do the entire performance load again on the fast 3G network itself, maybe it will decrease a little bit less, more, right? So you will find, yeah, so that didn't make much like difference. So you can say 3.99, 4.04 is the same thing. It didn't make much of a difference. So CPU is not like making much of a difference. But if you have like a no throttling, you know, everything is flying high in the mobile itself. Now, if we have to measure in this mobile device as well, this is also a diagnostic tool, again, not an absolute number, um, because the percentile value is what the Google cares about. It does not care about absolutes. That means if you have like 100 users and 75% and 75 of those users have better performance in the green zone, let's say, as the Google defines it, then you pass the test. That's about it. I'll show you while this is happening. Let's let this happens, and then I'll just show you what I mean. There's this site called ping.gg, right, which is something that I think it was from Theo's startup or something, right? It's a website. We will do one analysis of that site and just show you what I mean by that statement, that 75 percentile statement. So you can see it's still in the mobile, it will be 47. This is the problem, right? Properly size image. See, this is too big. Now in mobile, it is saying there's also some property called sizes. I won't go too much into it, but that's how you can actually define multiple like sizes. Okay, you can define certain things. But if I just reduce this to say 480 by 240, build the whole thing again. Cool. Nest and start, and then reload. It is very like low. Then I'll just do another mobile. See, it's now 92. um, the reason being, first of all, this decreased, and this is like a measure of like whatever's, as long as it's above 90 you can just let it sail. The image is now properly sized. It is still saying that it is not properly sized, and that's because I have just used 480 or something, whereas if I would have used say 375 or whatever, it might be even 100. And there's a property called sizes which I just showed you in that prop. You can actually use that in order to define based on the width how much it should be. So it will be kind of like a media screen property. Okay. So you can have a maximum size, let's say 1980 and 1080, because you are targeting the desktop, which is a maximum size. But then you can define sizes, and based on those sizes, different screen or different viewport will have different sizes, right? And it will be out of the box optimized. So that's how you actually remove all this thing. Now the final thing that I will just showcase here is basically this part. There's a site by, I think it's PingGG. Yes, this is by Theo. What I'll do is I'll just copy paste this, go to speed page speed insights, and we'll just run this here, analyze, and you see this thing now. This is how your real users are experiencing this particular website, ping.gg, and it is passing. This is on mobile, this is on desktop, so it is passing on both. This is what this real user experience is basically dependent on the 75 percentile test which Google does on its own. How it does it, only it knows, but basically whoever is coming to this particular website even from mobile has good enough internet and CPU power to load this mobile in a very optimal manner. However, this is the score, because this score is now being done on this where it is, this emulated device, slow 4G. So basically the users of ping.gg, right, have better device in terms of mobile than Moto G Power, with Moto G Power whatever it is, have better internet than slow 4G. Fair enough, that's what it says. So if that is the case, you don't have to worry about this. But if this is failing, that means your user base is somewhere here. So just try to improve it and have it a go, hope your users are somewhere here, because improving this in any sort of like a framework which is dependent on JavaScript is a pain, huge pain, especially when the site starts becoming big, like very big, which is what most enterprise sizes are. There's this article also by calendar, I think it's Calendar, Lighthouse, Page Speed, NextJS, sites, mobile performance. Yes, this is what it is. Yeah, it's by Clark. It's by Clark. I won't pronounce your last name because I don't know how to do that. Is it Gun? You can read the methodologies, but what you'll find in terms of results is that 27 sites are only passing in all of the web core vitals, CWV. Web core vitals are basically these: LCP, FID, and CLS. Okay, these are the core web vitals. Now the problem is this FID will be replaced by INP in 2024 March, and as you can see, this is kind of like in an orange zone. So after 2024 March, that means after April month ends, and if the ping.gg site or any site for that matter does not improve in terms of this INP, right, or by any chance it goes to in the red marker because of the increase in feature or whatever, yeah, then it will fail. Okay, And this is just one page, which is the landing page. The problem happens when you have a website or a web app built on Next.js, where you have multiple landing pages because of the marketing reasons. And then the problem starts to happen, because your home page will be very good, but maybe the rest of the page won't be that good, right? Because of huge unused JS, especially in the domain of Next.js, where the underscore app.jsx or tsx or ts or js, uh, the code there will be served to pretty much all the web pages, all the routes. And the problem with that is, most of the time the rest of the routes, say if it's just a static page, doesn't even require whatever the provider and all of that thing that you have to do in the app file, but it has to be put in the app file if it has to be functioning properly throughout our site in other places where it is needed. So it's a very tricky thing, but this is how it happens. And if you notice here, this is where I'll just open it. We can just move it like so. And if you notice here, INP, right? See, we will start going down, down, down. Here is the INP, which is, but here this is failing, right? So we'll let it be. Here this is the 180 ms, and these are also fine. One is in orange, but as you can see, it failed here as well. Why? Because two are in orange. So we will also go down, 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 down. We'll keep going down until we find one again, these two. Let's see which one is actually fine. So this passed, right? Okay, so we found one site where it will pass on 2024 March, this part. Let's go, it will fail again. Let's go down, again failing, failing. There's another passing here, that's the second site which will pass. And then you will have like pass, yeah, it will pass as well. That's the third site, and that's about it. So basically the result will become even much worse after 2024 March. It will be 3 sites that will be passing with CWV. The rest of all the sites, 107, will be failing. And just go and read this. I can just put it right here if anybody wants later. I'll also put it, okay, I'll also put it somewhere else.